MHF4U Grade 12 Functions, Section 1.7. Today we'll be discussing and exploring operations with functions. So things like adding, subtracting, multiplying, and dividing functions both graphically and algebraically. So let's first look at an example here. A popular coffee house sells iced cappuccino for $4 and hot cappuccino for $3. The manager would like to predict the relationship between the outside temperature and the total daily revenue from each type of cappuccino sold. The manager discovers that for every 1 degree Celsius increase in temperature, there is an increase in the sales of hot drinks by 3 cups per day, and a decrease in the sales of hot drinks by 5 cups per day. So the function f of x is equal to 3x plus 10 can be used to model the number of iced cappuccinos sold, and the function f g of x is equal to negative 5x plus 200 can be used to model the number of hot cappuccinos sold. And the negative is there in front of the function for g of x because there's a decrease in the sales of hot drinks. So in both functions, x represents the daily average outside temperature, and in the first function, f of x represents the daily average number of iced cappuccinos sold, while in the second function, g of x represents the daily average number of hot cappuccinos sold. Perfect. Okay, so then this can tell us that, well, if two functions have domains that overlap, they can be added, subtracted, or multiplied to create a new function over a shared domain. And this can be, this further tells us that this can happen graphically or algebraically. So we have some examples here of various types of, addition, subtraction, multiplication, division of functions. So the first one being where we have a set of ordered pairs. So here we're talking about adding ordered pairs, for example, A. And what's important to note here is that when you're adding ordered pairs and they have the same x value, then that remains the same. So that's why we have negative 4, 6, but then the y value changes. So that's why we have the 6, because you add the 4 plus 2. And then for the second order pair, again, the x value is the same, so that stays as negative 2, but the y value added, so it becomes 5. 3, same thing. It becomes added, so x value stays the same, but the y value is 5. And for 4, the x value is the same, so it stays as 4. The y values are added, so it becomes 10. Then for D, we're multiplying them together. And again, when we're multiplying, the x values will stay the same, but the y values will change because because you're multiplying the two functions together, so the input always remains the same. That's why the x value stays the same, but the y value will change. And as a result, we have x is equal to negative 4, and then y is equal to 8 because 4 times 2. Similarly, we have x is equal to negative 2, y is equal to 4, etc., etc. It continues through the functions in the set of ordered pairs. So then question 2, use the graphs of f and g to sketch the graphs of f plus g. So here we have, for A, we have f of x is equal to, we have a point that's negative 4, 2, and we have another point that's 1, 6. And for g of x, we have negative 4, 1, and we have 1, 2. So once we add these together, we get negative 4, 3, and we get 1, 8. And that's exactly what's reflected in our final graph. We have negative 4, 3, and we have 1, 8 reflected in our final graph. Okay, then question 3, use the graphs of f and g to sketch the graphs of f minus g. So in f of x, again, we're going to write out our main point. So we have negative 4, 0, and we have 3, 5. And then for g of x, same thing, negative 4, 0, and 3, negative 2. And once we do that, we're going to subtract the points. And again, the x values remain the same, the y values being subtracted. So here we have 5 minus 2, 7. And that's how we draw our new graph. Perfect. Okay. So now we show a multiplication. So we have the graphs of f and g. So f of x, we select our main points again, 0, 1, 4, 4, and 0, 3, and 4, 4. We're multiplying them through here. X values remain the same, y values are changing, so 0, 3, and 4, 16. And this is done algebraically. So let's say you have f plus g, then f of 2 will equal to 3, and g of 2 will equal to 5. So then you do f plus g of 2 is equal to 3 plus 5 is equal to 8. So that's how you can kind of understand this algebraically, is that when we do the change, we're doing that change to the input, which is x is equal to 2. And so that's why the change only occurs over our y value. So I hope this explained section 1.7 in more detail, and I hope the examples clarified some things for you. As always, if you have questions, feel free to contact our tutors on our website. And thank you for watching.